We're going to further analyze the revised setup that we did, keeping in mind that we started with a current setup that had some problems with it, and then we made some revisions to correct the air-to-fuel ratio. To continue this analysis, we're going to go to the jetting calc, and we have to make sure we've selected the correct one. That's the middle one that we have, so that is the one we're using. Okay. And we have three calculators here. There's main bypass, there's engine nozzles, and jetting from pressure. We previously illustrated determining the main bypass to hold a specific air-to-fuel ratio, and then we illustrated instead changing the engine nozzles. And in fact, we further showed how we restricted which nozzles to change, and we got it down to just 2 nozzles that were easily accessible. Now we're going to look at this one, which is jetting from pressure. Go down to the bottom and make sure we have our weather. The correct weather is the same weather that we were at. And get jetting. Okay, now what this does is it computes both the main bypass and the nozzles to maintain the air-to-fuel ratio and the fuel pressure. Okay, what we're going to do is come down here, and I'm going to go ahead and change the weather from 93, I'm going to go to 80. And that recomputes the main bypass and the nozzles for the same air-to-fuel ratio, which is 4:1, and the same fuel pressure. Well, unfortunately, I don't want to have to change all 16, so let's go down here. And let's say I don't want to change the ports, so I'm going to go ahead and fix all the ports. Go ahead and get jetting. Okay, so all I would have to do is change the hat nozzles to an 045. Keep in mind that we were originally an 044, and I'd have to change my main from the 136 to a 133. With the same port nozzles, I would have the same air-to-fuel ratio and the same fuel pressure. That is key. The reason not wanting to change the fuel pressure is important is then you don't have to change the high-speed poppet. So the high speed is again opening at 5,500 target RPM. Let's come down here again to the... Now let's say that I don't want to change all my hat nozzles. I'm going to use the same rationale that we had in the previous video. Let's fix the front 4. And the last 2, which are the lubers in many setups, and let's go ahead and get jetting. And that says that all I got to do is change 2 of the nozzles and the main bypass, and I'll hold my same air-to-fuel ratio and my same fuel pressure. This is significant because once you've established a running fuel pressure, that's a pretty nice thing to change. Now let's go ahead down to this and let's make a dramatic change in the barometer. Let's go to a 27 in the barometer, which would be like going to a Midwest track that's up in the foothills. Let's go ahead and get jetting and see where we're at. Okay, that's telling me that I need to go to 2 really small hat nozzles in a much bigger main bypass, and that absolutely holds the same air-to-fuel ratio and the same fuel pressure, the same high-speed opening point of 5,500 RPM. Let's go down. Now keep in mind that I was holding everything the same and I was only changing these 2 hat nozzles. If you have a fuel distribution issue that was discussed in one of the previous videos, you may not necessarily be able to do as simple as a change. You might have to maybe change 4 nozzles to maintain a fuel distribution problem. Keep in mind this can all be worked out in virtual reality with ProCalc. It would be extremely cumbersome to try to work these kinds of things out on a flow bench or a dyno. Trial and error would be very lengthy. You can work out all these combinations ahead of time, including if you're going to be doing testing on a flow bench or on a dyno. You can profile combinations that are fixed with fuel distribution requirements, air-to-fuel ratio requirements, fuel pressure requirements. Those can all be done simultaneously in virtual reality with ProCalc. Thank you for your time.